This lesson is over proving angle congruence. The objective, students will be able to use postulates and theorems to do geometric proofs. So the first theorem we're going to talk about is the vertical angle theorem. Vertical angle theorem simply states that vertical angles are congruent. Vertical angles are all congruent. We kind of talked about that earlier, I believe. Linear pair postulate states that if two angles form a linear pair, they are supplementary, so they add up to 180 degrees. If two angles form a linear pair, so they make a straight line, then they're supplementary. And the right angle congruence theorem, all right angles are congruent. If you need to pause this to catch up, definitely make sure you do that before you go on. The next thing we have is the congruent supplements theorem. Now this one's kind of interesting. It states that if two angles are supplementary to the same angle, then those two angles are congruent. So if you look at the little picture we have, angle 1 and angle 2, they are supplementary. They add up to 180 degrees. They would make a straight line. Angle 2 and angle 3 also add up to be 180 degrees. So that means angle 1 and angle 3 are congruent to each other. They're the same angle measurement. Now to kind of give you a little bit of an idea of what that looks like, if angle 1 was 30 degrees, then angle 1 and angle 2 add up to be 180, so angle 2 would have to be 150 degrees. Well then, if angle 2 and angle 3 are supplementary, they have to add up to be 180, so that means 3 has to be 30, because 30 is the only number that if you add it to 150, it gives you 180. And again, you kind of look at it this way as well. If I made angle 1 30, that means this has to be 150. Angle 2, we just said was 150. That means angle 3 has to be 30, because that's the only thing you can add to 150 to get 180. So they've got to be congruent. Now, that's the most important part of this supplementary theorem, the congruent supplementary theorem. But the secondary part of that is this also applies if they are supplementary to two angles that are congruent. So just really quick, if I told you for this one, before I start, this is the given. Let's just say I'm telling you that angle 2 is congruent to angle 4. So this angle and this angle are congruent. So if angle 1 is 30, that means angle 2 has to be 150. Well, I told you that 2 and 4 are congruent, so that means this has to be 150. Well, then again, if 4 and 3 are supplementary, that means that 3 has to be 30 degrees, because that's the only thing that you could add to 150 to get 180. So if that second part is a little bit confusing, don't worry, we're definitely going to use the other parts a lot more. Then, similar, we have the congruent complements theorem. If two angles are complementary to the same angle, then the two angles are congruent. And again, the same reasoning. If angle 4 and angle 5 add up to be 180, and angle 5 and angle 6, add up to be 90, said the wrong thing. Angle 4 and angle 5 add up to be 90, angle 5 and angle 6 add up to be 90, then angle 4 is congruent to angle 6. So same thing as this little picture. Again, I could do the same example where I say that this is 30, so then angle 5 has to be 60 because it makes 90-degree angle. Angle 5 and angle 6 add up to be 90, so angle 6 has to be 30. Same concept. And then again, just like the last one, this also applies if they are complementary to two angles that are congruent to each other. And again, it's the same kind of thing we did at the bottom of the slide. So let's do this proof really quick. It says, given lines L and M, prove the angle 1 is congruent to angle 2. Now, you might look at this, and some of you guys are going to say, well, they're congruent to each other because they're vertical angles, and due to the vertical angle theorem, they are congruent. And if you said that, you would absolutely be correct. However, they are having you fill in the blanks for this, and so it's going to be a little bit of a different, they're looking for something different than the vertical angle theorem, but I want to make sure you guys realize that that is true. You could do this in one step just by saying angle 1 and angle 2 are vertical angles, and they're congruent due to the vertical angle theorem. But that's not what they're looking for this one, and you know that because we start with our given. They start saying angle 1 and angle 3 are supplementary. So angle 1 and angle 3 make up this straight line. They're supplementary. That's the linear pair postulate. If you want to just put LPP, that's fine. Then angle 2 and angle 3 are a linear pair, are supplementary, so that makes a linear pair. Remember, we said linear pairs are supplementary. So then angle 1 and angle 2 are congruent, and again, I know they're vertical angles, but since we talked about the linear pair postulate, and since we were talking about things being supplementary, that means these are congruent due to the congruent supplements theorem. And if you want to simplify this to just congruent, just put the symbol and then supplement theorem. For that last step, you can do that as well. Honestly, if you had one like this on the test where you did just put vertical angles, I give you credit for that because technically that does mean they're congruent. So I can live with that as long as you put that as your reasoning. So let's do some practice with angle congruence theorem. And I'm going to be honest with you, I did this already. I got halfway through and then I quit because there's probably 3 or 4 different ways you can look at these problems. I think the easiest is to say, so angle 5 is supplementary to angle 2. So I know angle 5 plus angle 2 is equal to 180. Then it says angle 3 is supplementary to angle 2. So angle 3 and angle 2 is also equal to 180. And then they tell you find angle 3. So we're trying to find this angle here. And they're giving you angle 5 is 100. So angle 5 is 100. So over here, I'm going to put that in. So 100, and we have to add it to be 180, so that means angle 2 has to be 80. And if you want to, you can completely solve that. If you want to make it more like algebra, and subtract 100, so angle 2 is equal to 80, you can do it that way. Or again, most of you guys are good enough at math by now that you can just say, you know it has to add up to be 180, so 100 plus 80. So if angle 2 is equal to 80, then over here, angle 2 has to be equal to 80. So then what does angle 3 have to be? It's got to be 100. So that's a good way to reason through this and actually do all the math. But the other thing is, again, this is just trying to get you to get practice and prove the supplementary angle theorem, where angle 5 and angle 2 are supplementary, angle 3 and angle 2 are supplementary. So angle 5 and angle 3 have to be congruent because they're supplement to the same angles. Same thing with the next one, except for it's complementary, so it adds up to 90 degrees. Angle 1 plus angle 2 is 90 degrees. Angle 2 plus angle 5 is 90 degrees. Angle 5 is 40. So that means angle 2 has to be 50 to add up to 90. So angle 2 over here is 50, which means angle 1 has to be 40. So angle 1 is 40 degrees. And again, that's just kind of helping us prove that that complement angle theorem, the congruent complements theorem, is in fact true. I will say this is probably a bad time to talk about this, but the difference between theorems and postulates, I would love to like really tell you what's the difference between theorems, postulates, definitions. But honestly, I don't think you're going to remember it. I think it's going to confuse you more than it's going to help you. So if you accidentally say like the linear pair theorem instead of postulate, I'm okay with that. You will have a bank of reasons on the test, so it will say it in front of you, so hopefully you can get it. But I think postulates and theorems are very confusing already. I'm not going to try to bog you down with those details, so I'm going to be very open-minded about that. So angle 1 is supplementary angle 2, angle 2 is supplementary angle 3. So angle 1 plus angle 2 supplementary is 180 degrees. Angle 2 plus angle 3, 180 degrees. Find angle 3 and angle 1 if angle 2 is 30. So angle 2 is 30. So angle 1 has to be 50, and angle 3 also has to be 50. Angle 1 is equal to 50, and angle 3 is equal to 50. Again, you can do the math like I was doing, or that's just kind of confirming the congruent supplement theorem. And then number 5, the last one, angle 1 is complementary to angle 2. Angle 2 is complementary to angle 3. What's complementary? We add. Angle 3 and angle 1, if angle 2 is 60. So angle 2 is 60. That means angle 1 is 30 because it adds up to 90 degrees. Not 36, that's 30. And angle 3 also has to be 30. That adds up to 90 degrees. So again, I know some of you guys are like, why are we doing this when we know they have to be congruent because of the congruent complement theorem? But I'm just kind of showing you this so you kind of understand and so you know why that they're equal or why they're congruent. So let's do this next one. Find the value of x and y in the diagram below. So the biggest thing with y, we can't solve that right now because we don't know a lot of information. But these angles are vertical angles, so they're congruent. So we can start out with 2x plus 21 is equal to 4x. This is looking a lot like a question we had last chapter. So subtract 2x. We have 21 is equal to 2x. Divide both sides by 2. 21 divided by 2 is 10.5. 10.5 is equal to x. So we solve for x. That's great. But then what's y going to be? Now that's where we sub that 10.5 back in. It doesn't matter. You can sub it into this one or this one. It doesn't make any difference because you're going to get the same answer because they're congruent. So I'm going to sub it into 4 times 10.5. I'm going to sub it into this one. That means this is 42. So if this is a 42-degree angle, this makes a straight line. So 42 plus y is equal to 180. So I almost put 90. Y is equal to, did it again, 180. So subtract 42, subtract 42. That ends up being 138 for y. So y is 138 degrees. So this one, if you try to do the vertical angles, we have 3x is equal to 2y plus 5. We can't solve that because we have two variables in there. So we first can solve the x because that is a linear pair. So I know they're supplementary. 75 plus 3x is equal to 180. Subtract 75. Whoops. Three x is equal to 180 minus 75 is 105. Divide both sides by 3 is 35. X is equal to 35. So we solve for x. Now to find y, we have to sub that x back into here. So 3 times 35 is 105. So 3 times 35, that's 105. It is equal to 2x plus 5. So again, subtract 5. 100 is equal to 2y. Divide by 2. Y is equal to 50. And I guess I should specify that y is not 50 degrees because you'd still have to sub in 50 for this y. Same thing, x is not equal to 35 degrees because you'd have to sub it in for this x. So the last couple ones of these are proofs. So I think I have 3 or 4 proofs here for you at the end, just to get some practice with this. So they give you angle 1 and angle 3 are congruent. So I'm going to mark that. Since it's given, since they give me that, angle 1 and angle 3 are congruent to each other. I want to prove that angle 4 and angle 6. Now, I'm not going to mark that on my graph or on my picture because it's telling me to prove that. So we don't necessarily know if it's true yet. We need to make sure we prove that. So angle 1 and angle 3 are congruent. That's given. So that's perfect. Angle 3 and angle 6 are congruent. So angle 3 and angle 6 are congruent. Let me use the same color. So angle 3 and angle 6 are congruent. We know that because the vertical angle theorem. Then this is the first one we had like this. We don't know what the statement is over here, but they gave us the reasoning is the transitive property of congruence. So the transitive property of congruence, that's the one that was not plus. So we did it with equality. We said A is equal to B and B is equal to C. That means that A is equal to C. So for congruence, it's the same thing. They're just all congruent. So that's the property they're talking about. So let's see. If you look at their A and B's, it kind of looks like the 1, 3s, and 6. So we're looking at those previous ones. So if angle 1 and angle 3 are congruent, and angle 3 and angle 6 are congruent, that means angle 1 has to be congruent to angle 6. And we know that because that transitive property. Then the next one, that means angle 1, I guess that's what we did, so I should have done it this way. So they gave us the angle 1 and angle 3 are congruent. We figured out that angle 3 and angle 6 are congruent, and what they're saying is that angle 1 and angle 6 are congruent. So they're all those are marked are congruent to each other. Angle 1 and angle 4 are congruent. Well, how do we know that? Well, that's the same thing. That's the vertical angle theorem. Supposed to be an H, sorry. And angle 6 and angle 4 are congruent. So let's see what that reasoning would be. So that, I believe, is going to be, that's going to be the transitive property again, because it's written a little bit backwards, but if angle 1 is congruent to angle 6, and angle 1 is congruent to angle 4, that means 4 and 6 are congruent. So that's going to be the transitive. If you just put transitive property, that's fine. Technically, it's of congruence, not equality, but that's okay. And I realize that should be TRANS, but that's okay. So moving on to number 9. Well, actually, you'll be really familiar with some pictures that look like this a little bit later, but they're saying I'm giving you the angle 2 and angle 5 are congruent to each other. So I'm proving that angle 8 and angle 4 are congruent. So the first thing is our given. So what did they give us? They said that angle 5 is congruent to angle 2. That's the given. Now they're saying angle 2 and angle 4 are congruent. That is the vertical angle theorem. Now again, we have our reasoning. So it says the transitive property of congruence. So again, if angle 5 is congruent to angle 2, and angle 2 is congruent to angle 4, that means angle 5 has to be congruent to angle 4, to that transitive property. So now they're saying, so again, it really helps if you're going through this to update your picture as you go. So angle 2 and angle 5 were congruent. Angle 2 and angle 4 are congruent. So now they're saying that angle 4 and angle 5 are congruent to each other. So they're saying something is congruent with vertical angles. So there's a bunch of other ones we could put down for this. There's a lot of vertical angles in this. But we kind of, again, we want to make sure we're going towards that 8 and 4 are congruent. So I'm going to say, I want to talk about 8. Well, the one that's vertical with 8 is 5. So it's got to be angle 5 is congruent to angle 8. Because again, this next step, I'm talking about 8. That's where I'm headed. So what's vertical angle to number 8? Angle 5. So that means angle 8 is congruent to angle 4. And again, that's going to be that transitive property. Because again, if you look at step 3 and 4, we have angle 5 is congruent to angle 4, angle 5 is congruent to angle 8. So if angle 5 is congruent to 4 and angle 5 is congruent to 8, that means 4 and 8 have to be congruent to each other. How about number 10? Given B is the midpoint of AC, so we know AC is the, or sorry, B is the midpoint of AC. So BD, we also know BD is congruent to AB. And again, it's kind of hard to say what this midpoint had to put that on our graph, but I'll tell you that once we get there. So BD is congruent to AB, that's given. Then it says B is the midpoint of AC. Well, this one, again, how do we know that? Well, that's given to us as well. So this one, the first 2 steps are given. That's fine, that happens. So I know that AB is congruent to BC. So AB and BC are congruent. How do we know that? Because that's what the midpoint means. So I would say the definition of midpoint, the definition of midpoint is that point cuts that exactly in half. There's probably some other ones you can put for that, but that's what I'm going to list, the definition of midpoint. Then BD is congruent to BC. So BD is congruent to BC. Well, how do we know that? Well, again, this is going to end up being the transitive property. If I know that AB is congruent to BC, and I know DB is congruent to AB, that means DB and BC have to be congruent. So DB is congruent to AB, BC is congruent to AB. They're both congruent to the same thing. That is that transitive property. And you're going to have some of these here not too long where it's the definition, because that's what it is. How do we know they're congruent? Well, because that's the definition of a midpoint. You told us it was the midpoint. By definition, they have to be congruent. So we have two more here. Given Rj and M are collinear, so they're on the same line. That's what they show us. Rj is equal to 3. Rm is equal to 8. I want you to prove that Jm is equal to 5. So this is a really good one. So, number one, Rj and M are collinear. Rj is equal to 3, Rm is equal to 8. That is the given. Then it says Rj plus Jm is equal to Rm. That is, how do we know that? How do we know that Rj plus Jm, when you add those two segments together, it equals the whole thing Rm. That is the segment addition postulate. That's from last chapter, but we need it here because that's how we know that. That's how we know Rj plus Jm is equal to Rm. So what about 3 plus Jm is equal to 8? Well, how do we go from step 2 to step 3? Well, we know Rj is equal to 3, so I just sub the 3 in there for Rj. We don't know Jm, but we know Rm is 8, so I just sub that in there. So that's the substitution. So again, all we did is sub numbers in for that. Since we subbed those numbers in, that's substitution. So then we found Jm is equal to 5, and the reason I figured that, and there's probably other reasons for this, but I'm going to subtract 3 from both sides to solve that, and so that's going to be the subtraction property. And the last one, so given C and B are complementary and angle C is 50. So they don't give us a picture for this one. We might not need it, but I'm going to draw one just in case. So I know C and B are complementary, so they add up to be 90-degree angle. So I'll make this 90-degree angle. I'll separate it. This is angle C and angle B. And they say angle C is 50. So that's all my given. So that's what I make my picture. And that's the first step. They say that. They say all of that. So that's my given. So I have angle C plus angle B is equal to 90 degrees. That is the definition of complementary. Complementary angles. Again, you can abbreviate kind of like that. On your bank of reasons on the test, you'll see some of the abbreviations if you want to use those. But again, as long as I can tell what you're talking about, that's the main thing. Just make sure I can tell. So what's the number 3? What's the substitution for number 3? Well, we just substituted in this C for 50. So we have 50 plus measurement of angle B is equal to 90. And then this one, now we have a blank for both. We have a blank in the reason and we have a blank for the statement. Well, the good news is I know the last step in every one of these proofs has to be what you're trying to prove. So measurement of angle B is equal to 40 degrees. But how did we figure that out? Well, again, just like the last one, if you subtract 50, that's how we found that. So that is the subtraction property. So this was a little bit of a longer lesson because we did a couple extra proofs there at the end, just for extra practice. Make sure you're watching those. That'll help. If you have any questions, make sure you let me know.